Okay, 6th grade. Today we'll be reviewing for the topic test 2 and 3, advanced and regular math. Okay, it's only one question that does not pertain to regular math and only for advanced, but when we get there, I'll let you know, okay? All right, number 1, what is the greatest common factor of 18 and 24? So we are looking for the GCF, or the greatest common factor of 18 and 24. So we have 18 and we have 24. The factors of 18 are 1, 2, 3, 6, 9, and 18. The factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So we're looking for the common factors. Those common factors, the greatest common factor, the biggest, will be 6. So for number 1, the answer is 6. Number 2. Number 2 says, what is the least common multiple, or LCM, of 12 and 18? All right, so we're looking for the LCM of 8 and 12. I'm sorry, 12 and 8, not 18, 12 and 8. So the multiples of 8 will be 8, 16, and 24. The multiples of 12 are going to be 12, 24, and we can go ahead and stop right there. Okay, so because they asked for the least common multiple. So therefore, the least common multiple is going to be 24. Okay? Number 3. Number 3 says, what is the GCF and the LCM of 5 and 10? So for this question, you need 2 answers. The first, they ask for the GCF, the greatest common factor, of 5 and 10. So the factors of 5 are 1 and 5. The factors of 10 are 1, 2, 5, and 10. So the greatest common factor is going to be 5. And then they ask for the least common multiple, the LCM of 5 and 10. The multiples of 5 are 5 and 10. We can stop there. The multiples of 10 are 10 and 20. And we can stop there. Because they asked for the least common multiple. So our least common multiple will be 10. So please pause the video so that way you can take notes and you'll know the difference between a factor and a multiple, and you won't get confused. Okay, now we'll be dealing with these word problems. Okay, number 4, it says Miss Mitchell bought 12 Bath and Body Works candles and Miss Ballard bought 2 Bath and Body Works lotions. What is the ratio of candles that were bought to the total number of items bought? Remember, I always tell you, when you get to a word problem, read it over and over and over again until you understand what it is that they are asking you to do. And then break it up into smaller parts to solve the equation. All right, so it says Ms. Mitchell bought 12 Bath and Body Works candles and Ms. Ballard bought 2 Bath and Body Works lotions. But the question is, what is the ratio of candles that were bought to the total number of items bought? So this one is number 4. So they asked for the ratio of candles that were bought. So how many candles were bought? 12. And then they said to the total number of items bought. So candles were bought and lotions were bought. 12 candles, 2 lotions. So 12 plus 2 will then give you 14. So the ratio of candles to the total number of items bought were 12 to 14. And remember, you can write ratios in 3 ways. In this form, 12 to 14, or 12 over 14 as a fraction. Okay? All right, number 5. Chantrell and Daphne paid $18 for a dozen of gourmet cookies. What is the unit cost for each gourmet cookie? Okay, so we know that Chantrell and Daphne paid $18 for a dozen of gourmet cookies. A dozen. How many is in a dozen? We know 12 is in a dozen. But they are asking what is the unit cost for each gourmet cookie. So we need to find out how much one cookie costs. We know that 12 of them cost $18. So we need to divide 18 divided by 12. So when we do that, 18 goes into the house, 12 goes outside, 12 goes into 18 one time. 12 times 1 is 12. 18 minus 12 gives us 6. We now need to add a decimal with at least 2 zeros. And don't forget to add that decimal up top. So now we can send down that 0. 12 divided by 60 gives us 5. 12 times 5 gives us 60. And we have 0. So, and we'll just add a 0 for the placeholder since we are talking about money. So, how much did one gourmet cookie cost? One gourmet cookie costs $1.50. Please pause the video, take down the notes, practice it if you need to understand. Okay, now we're dealing with number 6. And it says, which of these is an example of a heart rate beating at an average rate of 90 beats per minute? Okay, and they give us choices. So which of these is an example of a heart rate beating at an average rate of 90 beats per minute? So we have 90 beats per minute. So it says per minute, that means per 1 minute. So here, since they give you the information in these options, they give you the beats and they give you the minute, and they need you to find out what is equal to 90 beats per minute. So it will be easier for you to write it in a proportion. So we have 90 beats. Beats is going to be our numerator, the minutes in our denominator. So the same pattern you use here, you're going to use it on this side. Now, what you'll need to do is go through these options, okay? Now, you have fractions here. I always tell my students, and I follow the same thing, I don't like looking at fractions. And if you don't, then turn them into decimals, okay? So, let's look at these. Let's go with C. C says 45 beats per half of a minute. Now we already know that half of 90 is 45 and half of a minute is half. So we have 45 beats, and remember we following the same pattern. Beats are up top and minutes are below. So half of a minute will be 0.5. So from here, we're going to cross multiply. And when we cross multiply, we should get an equal answer on both sides, meaning that each side should say the same thing. 45 times 1 says 40. 45 times 1 is 45. 90 times 0.5, guess what? It's 45. So it checks. So the answer would be C. But let's look to see what happens when we try B. So again, we set up the problem. 90 beats per 1 minute is equal to, and it says 180 beats per 1/4 of a minute. 1/4 as a decimal would be 0.25. When we cross multiply, 1 times 180 gives us 180. 90 times 0.25, 0.25 and 90, 3. 9 times 5 is 45. 4 goes up here. 9 times 2 is 18, plus 4 is 22. 9 times 0 is 0, plus 2. All right. And then, all right, so therefore, 22.50. As you can see, they are not equal on both sides, because 180 definitely is not equal to 22.50. Okay, so as you can see, C is the correct answer. Why? Because when we put it in a proportion, they equal out on both sides. So please pause the video so that way you can take notes. All right. Now, number 7. We have a table of bags of candy needed. And this column, we have bags of candy with 3, 6, 9, and 12. Here we have cost in dollars, 15, X, 45, and 60. And it says, Ms. Ballard and Ms. Mitchell need to go to Sam's to get bags of candy for the students on Halloween. They made a table to show the number of bags and the cost of the bags. The ratio of bags to the cost of bags is a constant proportion. Find the missing number in the table. All right, so they said it's a constant proportion. So 3, 6, 9, and 12. As you can see, it is increasing by 3 all throughout. Here, 15, X, 45, 60. But we have to find X. So they said that it is a constant proportion. That means that it is going to increase. One side, as we see, is increasing by 3 all the way. The other side should increase by the same number all the way. So 45 to 60 is an increase of 15. That means that 15 to X should be plus 15. It should have increased by 15. That means that 30 will be our X. Because 15 times 2 is going to be 30. So 15, the X, we said was 30, 45, 60. As you can see, it increased by 15. Or you can try it another way. 3 times 5 gives you 15. 6 times 5 gives you 30. 9 times 5 gives you 45. And 12 times 5 gives you 60. So therefore our X will be 30. Scroll up. All right, number 8. Mr. Felix wants to buy ties for all his 5,000 role models. He wants to spend no more than $5 per tie. Which of the following purchases will he, it's supposed to say can he make, I'm sorry. Select all that apply. All right, so he wants to spend no more than $5. That means that he wants to spend $5 or less. So they said, which of the following purchases, A, B, C, or D, can he make? We're going to select all that apply. Now remember, when you see a question that says select all that apply, that means that it may be more than one answer, okay? That is not always the case, but it may be more than one answer, okay? So let's go through these. A says 8 ties for $40. So that means we just need the cost of 1 because he wants to spend no more than $5 per tie. So no more than $5 per one tie. So we have 8 ties for $40. We need to see how much one tie is. So we just divide. 40 divided by 8 will give us 5. He wants to spend no more than 5. So 5 is our magic number or less. So can he make that purchase? Yes, he can. B, it says 15 ties for $80. So we take that $80 and we divide it by 15. So when we divide it, 15 goes into 80. Let's see. We know that 2, 4, 60, 75. So 6 times 5 is 30. 6, 7, 8, 9. Too much. 15 and 5. 5 times 5 is 25. 5, 7, 75. So 5 and then 75, and then that's 5 left over. Uh-oh, we're getting a remainder. Okay, so here, when we divided 80 divided by 15, as we were dividing, we got the 5, but then we got a remainder. That means that we're gonna have left over. That means it's gonna be more than $5. So there's no need to go any further with this, okay? Do not waste time. It's more than $5. Therefore, he will not be making that purchase of 15 ties for $80. It's just too much. So let's try C. C says 17 ties for $60.25. So when we divide $60.25 divided by 17, don't forget that decimal at the top. So here, 17, can 17 go into 60? It can. Let's see how many times. Let's try 4. 4 times 7 is 28. 4, 5, 6. Oh, good. All right, so 4. Nope, too much. So 17 and 3. 3 times 7, 21. 3, 4, 5. Yep. All right, so 3. Look at that, 3. No need to go further. $3. Okay? So remember, like I said, it's no need to waste time because we're spending no more than $5. $3 is less than 5. So we already know, yes, we can make that purchase. So let's move on to the next one. D. 9 ties for $32. $32 divided by 9 gives us $4. 32 and 9. 9 goes into 32 3 times. 9 times 3 is 27. Again, $3. $3 is less than $5. So therefore, we can make that purchase. So your answers should have been A, C, and D. A, C, and D. He can make those purchases. Please take notes. Pause the video if you need to. When you're ready to move on, just press play. Okay, scroll up. All right, number 9. Come down a little. Number 9 says, Ms. Johnson bought 6 dozen cupcakes for $23.94. At this rate, what would be the price of 5 dozen cupcakes? Okay, a lot of students look at this question and get very discouraged. Don't. Ms. Johnson bought 6 dozen cupcakes for $23.94. At this rate, what would be the price of 5 dozen cupcakes? Okay, we already know how much 6 dozen cupcakes cost, but they're asking us how much 5 dozen costs. So the first thing that we need to do is find the unit rate of the cupcakes. So, if we can find out how much 1 dozen costs, then we can find out how much 5 dozen costs. So, when we divide $23.94 divided by 6, we get $3.99. So now we know how much 1 dozen cupcake costs, but that's not what they asked. They asked us, what is the price of 5 dozen cupcakes? Well, if you already know how much 1 dozen is, so now all we have to do is multiply by 5 to get how much 5 dozen are, which will be $19.95. So please don't look at questions like these and get discouraged, okay? So if you already know that 6 dozen cupcakes are for that price, just take it down to how much 1 costs. Then you can find out how much 5 dozen are, okay? Now let's scroll up. Let's scroll up. All right, number 10. The PTA had a meeting and served 5 pans of spaghetti. When the meeting was over, there were 2 pans left. Which of the following shows how much of the spaghetti had been eaten? Select all that apply. And then we have answers. We have answers in the forms of fractions, percents, and decimals, okay? So, the PTA had a meeting and they served 5 pans of spaghetti. Okay, so all in all, the whole number was 5. That's the whole. When the meeting was over, there were 2 pans left. Which of the following shows how much of the spaghetti had been eaten? So they don't want to know how much was left. They want to know how much was eaten. So we have 5, it's 2 pans left, nobody wanted those. 3 pans were eaten, okay? Because if we take away 2 from 5, we get 3. So, but they have our answers in fraction form and in decimal form. We need to find out what is the decimal form of 3/5. And how do we turn a fraction into a decimal? We just divide. The 3 goes into the house, the 5 goes outside. Here, 5 cannot go into 3, not even on a good day, okay? So we have to add a decimal with 2 zeros. And don't forget that decimal up top. 5 does go into 30 6 times. 5 times 6 gives us 30. And the placeholder is a 0. So we know our answer is going to be 0.60. Do we find 0.60? Yes, we do. D, 0.6. Now, it says select all that apply. That means we may have more than one answer. So, let's go ahead and take this. Let's take it to percent. And we just move that decimal place over, and now we have 60%. Do we find 60%? Yes, we do. B. But now let's take it a step further, and let's turn it into a fraction. And how do we turn a fraction into a percent into a fraction? We take this number, 60, and all percents are out of 100. Or we can take this decimal, 60, and look at the place value, 100. And do we have that? Yes, we do. E. So our answers would be B, D, and E. B is 60%, D is 0.6%, and E is 60 over 100. Okay? Go ahead and pause the video and take notes if you need to. Let's go ahead and scroll up. All right, number 11. Ms. Forteza asked 125 elementary students if they enjoyed Trick-or-Treat Street. Exactly 67% of the students said they enjoyed it. What was the total number of students who said they enjoyed Trick-or-Treat Street? So, they asked 125 students. They said exactly 67% of the students said they enjoyed it. But they're asking us what was the total number of students who said they enjoyed it. So we need to find what is 67% of 125. So how do we do that? We multiply. We multiply 125 times 0.67. And when we do that, we get 83.75. Now, we're talking about people, students. So I want to see a classroom where you have 83.75 students stand up. It's not going to happen. So we're talking about people. You can't just cut people in half. Well, you can, but don't do that. Okay? So we have to round up. So therefore, it will be 84. 84 students said they enjoyed Trick-or-Treat Street. Okay? Now, number 12. Ms. Mitchell, that's me, is trying to lose weight. Yes, I am. She walked 6.5 kilometers around the school. Using the conversion, 1 mile is equal to 1.6 kilometers or kilometers. About how many miles did she walk? Round to the nearest whole number. Okay, so they said that I walked 6.5 kilometers. This is number 12. And our conversion is 1 mile is equal to 1.6 kilometers. So remember, we are going from a smaller unit to a larger unit. Because we're going from kilometers, we're going to miles. Okay, so we're going from a smaller unit to a larger unit. When you do that, you have to divide. Okay, so we have 6.5 kilometers, that was the information that was given to us, divided by the conversion, 1.6. When we divide 6.5 divided by 1.6, we get 4.06. But they asked us to round to the nearest whole number. This is the whole number right here, this 4. When we look next door, it is a 0. That means it is 4 and below. Because remember, 4 and below, this number stays as is. If it was 5 and up, then you will round up. So being that this is a 0, we're going to stay at 4. So therefore, I walked 4 miles. Go ahead and pause the video and take notes. Scroll up. All right. Number 13. Mr. Nelson is trying to separate some of the colors of Nerds candy. There are 1/2 of a cup of red Nerds for every 1/2 of a cup of purple ones, and every 1/4 of a teaspoon of green ones. Which of the following rates are unit rates equivalent to the ratio shown above? Select all that apply. Remember, select all that apply could mean it's more than one answer, but not all the time. All right, remember what I told you about fractions. If you don't like looking at fractions, just like me, I turn them into decimals, okay? So, there are 1/2 of a cup of red. So here we have red, and then we have purple, and then we have green. All right, we have 1/2 of a cup of red. 1/2 as a fraction is written as 0.5 as a decimal. And then purple, same thing, 0.5. but now green is 1/4, and that would be 0.25. Okay? But now let's double it. Okay? So let's multiply it by 2. All right, so if we did, then we would have 1.0 of red, 1.0 of purple, and for green, 25 plus 25 would give us 50, so therefore 0.50 or 0.5, whichever you prefer, okay? All right, so now, and if for any chance you need to triple it, because what we're trying to do is see if these ratios are going to match up, okay? And that is how we get a visual of what we're doing. Because when we look at the options that they give us, you have 2 teaspoons of green nerds per 1 teaspoon of purple nerds. So it says 2 teaspoons of green, 2 teaspoons, we don't even see 2 teaspoons, and then for 1 teaspoon of purple. So here we look at purple, for 1 teaspoon, I will only have half. So that can't be right, because it's saying I will have more than green. So that can't be right. So B, what about B? 1 teaspoon of purple for 1 cup of red. No, 1 teaspoon of purple is right here, but it's the same ratio of red. So we know that's not it, because we're talking about teaspoons and cups. So we know that's not it. C says half a teaspoon of green, we have half, for 1 teaspoon of purple. Uh-oh, here it is right here. Half for green, 1 of purple. That looks good. So C is good. But let's go on to D. And D says 1 teaspoon of purple for 2 teaspoons of green. So 1 teaspoon of purple, 2 teaspoons, no, we don't see 2 teaspoons, no. So that can't be it. So therefore our answer will be C. So please pause the video and take notes if you need to. And let's scroll up. All right. Number 14. How many inches are in 10.5 feet? Okay. It says, again, a conversion. So, how many inches are in 10.5 feet? And then it has our conversion, 12 inches is equal to 1 foot. So, it's number 14. So remember what I told you about fractions. If you don't like looking at them, turn them into decimals. So they say how many inches are in 10.5 feet? So 10.5. And then they told us that 12 inches are equal to 1 foot. So remember, when you are going from a bigger unit to a smaller unit, you now have to multiply. Because we're going from a big unit, feet, to smaller units, inches, okay? Because remember, in the last one, we were going from smaller units to larger units, so therefore we had to divide. But here, we're going from feet to inches. So now we have to multiply. So when we do that, we have to now multiply 10.5 times 12. And that will give us 126. Because we are going from feet to inches. So they said how many inches are in 10.5 feet, and our conversion was 12 inches is equal to 1 foot. And remember, we're going from feet to inches, meaning large to small, and so therefore we have to multiply. So all we did was multiply. We turned 10.5 to 10.5 to make it easier to look at, we multiplied by the conversion, which is 12 inches, and then we got 126. So please take notes. And now we're going to scroll to our last question, and this is the question that I was talking about, number 15. And that is, what makes this line on this coordinate plane proportional? Okay, so we see this line on the coordinate plane, okay? And so our question is, what makes this line proportional? All right? So remember, for something to be proportional, it has to form a line itself, okay? So it has to be a line. So the first thing is a line. The second thing that makes it proportional is, remember, it has to pass through the origin. And the origin is right here with the coordinates of 0, 0. So not only does it have to be a line, it has to pass through the origin. And remember, the origin's coordinates are 0, 0. And that is it. I hope that you will be ready. Okay? So remember, if you have any questions, message me in the comment area or hit me up on Edmodo. Okay? Good luck, my 6th graders. May the force be with you. And I'll be here also to root you on as always. And have a good night.